Hello guys, welcome to another video in the series of coding. Today we are going to do the problem which is called find the city with the smallest number of neighbors at a threshold distance. There are n cities from 0 to n minus 1. You are given edges, right? So you are given an edges array which represents starting city and then the city to which you are going and the distance between the city. It's a bidirectional and weighted edge between cities. Okay, you have to return the city with the smallest number of cities that are reachable through some path and whose distance is at most distance threshold. If there are multiple such cities, return the city with the greatest number. Okay, let's try to understand this problem using this particular example. Let's say this is the city, right? And so this is the graph connecting the cities, and let's say the distance threshold that is given to us is equal to 4. So in the question they are first of all asking us, okay, first of all let's note down what is the question. So let's start with city 0. If we start from city 0, we will see what is the distance of city 0 from the remaining cities. Okay, let's see the distance of city 0 from all other cities. Okay, so distance of city 0 to city 0 should not be considered because it's the same city. Let's see the distance of city 0 with city 1. Okay, so 0 to 1, there it has a distance of 3. Okay, city 0 to city 2, what is the distance? The distance between city 0 to 2 is 3 plus 1, 4, right? 4 is the smallest possible distance. Now distance from city 0 to city 3. So if we start from 0 and we want to reach the city 3, what is the minimum possible distance? If we take this way, we will get 7, but we can do better. We can take 3 plus 1 plus 1. It will still take a distance of 5. 5 is the best possible that we can do. Okay, 5 is the minimum least possible distance between 0 and 3. Okay, so now we have all the distances. Now the threshold is given 4, right? That means there are only 2 cities which are having distance within the threshold. Okay, 3 is less than equal to 4 and 4 is less than equal to 4, but 5 is greater than 4, right? So this is not permitted. So there are only 2 cities for the city 0 which are lying within the threshold. Okay, within the threshold. So we should see the cities which have a distance within the threshold. So for 0 there are 2 such cities. Okay, so let me write the number of cities. For 0 the answer is 2. Okay, let us consider the next city. Let's take the next city as city 1. Now the distance between 1 and 0 is simply 3, right, which is the least possible distance. Distance between 1 and 1 we should not take. Distance between 1 and 2, so the minimum least possible distance is 1. Distance between 1 and 3, okay, this is one path, but it will be 4, right? So the shortest path will be if you start from 1 and go to 3, the shortest path will be take this path, so it will be only 2, right? So within 2 units itself you can reach. So in this case all the 3 distances are less than equal to 4, right? So they are within the threshold. So in this case the answer is 3. Okay, similarly let's write down the answer for city 2. So for city 2, distance between 2 and 0 is 4, right? We already have the distance here, so distance is 4. Distance between 2 and 1, we already have the answer here, it is 1, right? Distance between 2 and 2 is not necessary. Distance between 2 and 3 is minimum is 1, right? So again all of the 3 distances are within the threshold because all of them are less than equal to 4. So for this also the answer is 3. Okay, now let us consider the last city, which is city 3. So if we take the city 3, distance between 3 and 0 is already from the table we can get, it is 5. Distance between 3 and 1 we can already get from the table, it is 2. Distance between 3 and 2 is 1, and this is not considerable. So we have only 2 cities which are lying within the threshold, right? Because they should be less than equal to 4. This is the condition, this is the threshold that is given in the question. So only 2 cities satisfy the threshold. So now if we note these answers, we have to find out the smallest such answer, right? So in this case there are the smallest number of cities that we have is 2, right? 2 is the answer in all these answers, right? In all these 4 answers, which is the smallest answer? 2 is the smallest answer. We have to find the smallest answer, but 2 is the answer for 2 cities, right? Because see, here also we have 2, here also we have 2. So 0 and 3. In this case you have to return the maximum city. So the maximum city value is 3, right? So our final answer is 3. So 3 is our final answer. Let me repeat. So once we have calculated all the answers, right, which are the cities, the distance between cities which are satisfying this threshold, right, we have calculated our final answer. In this we have to see the smallest answer. Now the smallest answer is 2, but 2 is answer for 2 cities, 0 and 3. Since there is a clash, in this case you have to return the maximum city number. So in this case, instead of returning 0, we will return 3. Okay, we can return both 0 and 3, but we need to return only one answer, so we will return 3, because 3 has the smallest answer, which is 2. There are only 2 cities which are lying within the threshold for the city 3. Okay, now how do we solve this question? So first of all, we have to make this table, right, and then we have to calculate the answer. So making this table is nothing but finding the shortest distance between all cities, right? And whenever you see a shortest path algorithm, finding the shortest distance between all cities, okay, for all pairs, the algorithm that comes to mind is Floyd Warshall algorithm, right? It is the most important shortest all pairs algorithm, and the time complexity of it is O of n cube. So that will be accepted solution. So let's see the Floyd Warshall algorithm. So we have to basically build this table, right? So let's build this table using the Floyd Warshall algorithm. Let us see step by step how we are going to build this table using the Floyd Warshall algorithm. Okay, so let us start. So basically we have to just build the table, right, of the shortest distance. So what we will do in the Floyd Warshall algorithm, first we will build this matrix which we just discussed, right? So this is the matrix that we have, which is nothing but the distance between all such pairs, right? Now let's initially make all the distances as infinity. Okay, we don't know any distance, so what we'll do, we'll make all the distances as infinity. Okay, we have made all the distances as infinity because we don't know what is the distance between two paths. So very simple thing, we have just made we have made this matrix and we have made all the distances as infinity. Now we know that for these values, right, for the values of 0 0 1 1, which is nothing but the city 1 connected to the city 1 itself, right? So these distances are all going to be 0, because to go from city 1 to 0 to city 1 itself, the distance that you can have is 1, right? The distance you can have is 0, right? There is no possible distance. So for all the diagonal values, we are going to make it 0. Okay, very simple. Next, also very simple step. So let me repeat. So what we are going to do, we are going to make the diagonal values 0. Rest all values we'll keep as infinity as discussed. Okay, only the diagonal values I have made 0. Now next step in this algorithm is first of all, we will keep the distance which is given to us. Okay, for example, distance between 0 and 1 is 3, right? So since we know the distance between 0 and 1 is 3, why will we make it infinity? We will make it 3, right? So let me fill the values that are given to us already. Okay, let me fill the values that are given to us already. So distance between 0 1 is 3. So let me fill 3 here. Okay, similarly, distance between 1 and 0 is also 3, right? So let me fill 3 here. So let me make it 3. Okay, now let's see the next edge. Distance between 1 and 3 is also 4. So I will fill 4. Distance between 1 and 3 is 4, right? Similarly, distance between 3 and 1 is 4. So I will fill 4 here. Okay, let us fill 4. Okay, now let's go to the next edge. Distance between 2 and 3 is 1, right? So I will fill 1. Distance between 2 and 3, or distance between 3 and 2 is 1. So I can fill 1 here. So let me fill 1. Okay, now let's go to the next edge. Distance between 1 and 2 is also 1, right? So distance between 1 and 2 is also 1. So distance between 1 and 2, or distance between 2 and 1 is also 1. So I have completed all the possible edges. Okay, these are just direct connections that are given to me. Now this is not the shortest path, because we still have to fill lot of values. Lot of values are still infinity, right? They may remain infinity or they may change, we will see. Okay, so now this is a simple matrix that we have just declared or initialized. Okay, now let us see the algorithm. So the algorithm is simple. See what we are going to do. We are going to pick one node each time. Okay, let's say we pick the first node 0. Now we will keep 0 as the pivot, and for all other possible nodes, right, for all other possible nodes using 0 as pivot, we are going to find out if there is a shortest path using 0. Okay, so let's see what we are going to do. So let's see if using 0 we can get a shortest path for any other node. Okay, so we leave the node 0 and remaining nodes, okay, we are going to consider, and we are going to see if we can get any other shortest path we can change in this matrix using 0. Okay, so first let's see the first possible value. So let's see between 1 and 1. Okay, now this is 0, this is minimum 0. Okay, so nothing can be changed here. Let's see between 1 and 2. So what we are seeing is using 0, is there a path? Okay, is there a path from 1 to 0 plus 0 to 2? Okay, so let me write distance from 1 to 0 plus distance from 0 to 2. If this is going to be less than the distance of 1 to 2, right? If this is possible, then we will change the value here. Okay, so let's check if this is possible. What is distance between 1 to 0? The current distance between 1 to 0 is 3, right? So this value is 3. And what is the distance between 0 to 2? So distance between 0 to 2 is infinity, right? There is no possible path. This is infinity. So this value cannot be changed, right? Because infinity is not less than 1. If we had got this value to be less than this value, then we would have made the change. Okay, so we'll see other examples. So for now, this will be left as such. Now let's see for the next node. So what we are going to see, if distance between 1 to 0 plus distance between 0 to 3, okay, if that is going to be less than distance of 1, 3. So using 0, we are trying to see if we get a shorter path. So what is distance between 1 to 0? That is 3. What is distance between 0 to 3? That is again infinity. So this is not valid. Okay, so now let's go to the next possible path. So now let's see using 0, if there is a shortest distance like this, right? So from 2 to 1. So let's see if distance between 2, 0 plus distance of 0, 1, if that is less than distance of 2, 1. Let's see if this is valid. So what is distance between 2, 0? That is infinity, right? That is itself infinity. So again, this will also definitely not be true. So let's see the next possible case. Distance between 2, 2 is already 0. Let's see the distance between 2, 3. Okay, so we have to check if distance of 2, 0 plus distance of 0, 3, if that is less than distance between 2, 3. So what is distance of 2, 0? Again, it is infinity, right? So again, this is not possible because as of now it's not possible. Okay, so let's ignore and let's go to the next node. So we have to again check the same thing. So we have to check distance between 3, 0, if this distance plus distance between 0, 1 is that, if that is less than the distance between 3, 1. Okay, so what is the distance between 3, 0? It's infinity. So this is again not valid. So let's go to the next cell. So we have to similarly check if distance between 3, 0 plus 0, 2 is less than the distance between 3, 2. So what is distance between 3, 0? It is again infinity, right? So again, in all these conditions, it will not be valid. So this matrix will remain as such, right? As of now, we will not make any change to this matrix. So we have finished the iteration for the node 0. Okay, now let's try to do the iteration for the next node, which is node 1. So what we will do, using 1, if we can find a shorter distance. So let's see. So we'll leave this particular cells and we'll start with all other cells. Okay, so let's try to see for 0, 2 if we can find a better distance. So what we are doing, if the distance between 0, 1 plus, because 1 is the pivot, right? If the distance from 0, 1 plus distance of 1, 2, if that is less than the distance of 0, 2, we are trying to see if this is valid. If this is valid, we will make change here. So what is the distance between 0, 1? It is 3, right? It is 3. And what is the distance between 1, 2? The distance between 1, 2 is 1, right? It is 1. So in this case, this is less than the distance between 0, 2. The distance between 0, 2 is infinity as of now. So for the first time, we found 4 is less than infinity. That means what? That means there is a path between 0 to 2 via 1. Okay, via the node 1, there is a path which is having a better distance. Okay, so see, from 0 to 2 we have a better distance, right? 3 plus 1 is 4. 4 is less than infinity. So the distance between 0 to, we will change it in this particular cell. And what we will make it to? We will make it to 4. Okay, let's make it to 4. Okay, so we will make it to 4. So let me erase it and make it to 4. Now let's similarly go to the next cell. So what are we going to check? Again, we are going to check if the distance between 0, 1 plus 1, 3 is less than the distance between 0, 3. Okay, so what is the distance between 0, 1? It is 3. What is the distance between 1, 3? Distance between 1, 3 is 4. That is less than infinity. Again, it's true, right? So what we have got, 3 plus 4, 7. 7 is less than infinity. So again I will do the same thing. I will quickly make the change here. I will make this as 7. Okay. Now let's go to the next possible case. So we are ignoring all these cells. So we'll go to the next column. So again we'll check if the distance between 2, 1 plus the distance of 1, 0, if that is less than the distance of 2, 0. Okay. So what is the distance of 2, 1? So 2, 1 has a distance of 1, right? And what is the distance of 1, 0? 1, 0 has a distance of 3. So that is less than infinity, we have to check. So 4 is of course less than infinity. So we will change that value there and we will make it in 4. Okay. So this value will become equal to 4. Okay. Now let's go to the next possible cell. So similarly, this will be ignored. This will be ignored. Let's check for 2, 3. So you have to check if the distance from 2, 1 plus 1, 3 is less than the distance of 2, 3. So what is 2, 1? 2, 1 is 1. Okay. What is 1, 3? 1, 3 is 4. We have to check if this is less than 2, 3. 2, 3 is 1. 5 is not less than 1, right? So this is not valid. So we'll just ignore and we'll go to the next cell. Now again we have to check if the distance, if we are getting a better distance of 3, 0. Of course, okay, let's quickly check. So if the distance of 3, 1 plus 1, 0 is less than the 3, 0 distance, then we'll update it. So what is the distance of 3, 1? It is 4. What is the distance of 1, 0? It is 3. So of course it is less than infinity. So we will make here 7. So we'll change and make it 7. Okay. Now let's check 3, 2. Okay. Let's check 3, 2. So we are checking if 3, 1 plus 1, 2 is less than 3, 2, right? So what is 3, 1? 3, 1 is 4. What is 1, 2? 1, 2 is 1. Okay. So we have to check if that is less than 3, 2. 3, 2 is 1. This is not valid, right? So this will not be valid. Okay, so that's it. We have finished the iteration for node 1 also. So what we did, first we made node 0 as pivot, then we made node 1 as pivot. Now we'll make node 2 as pivot, then we'll make node 3 as pivot. Let's quickly see this. So now our node 2 is pivot, right? So we have to ignore this and remaining all other distances we have to check. So let's start with 0, 1. So we have to check if 0 to 2 plus 2, 1, okay, distance between 0 to 2 plus distance between 2, 1 is less than the distance of 0, 1. Okay, so we'll check that. What is the distance of 0 to 2? 4. What is the distance of 2 to 1? 1. We have to check if it is less than 0, 1, which is 3. This is false, right? So we don't have to make a change here. Let's check for the next possible cell. So you have to check if the distance from 0 to 2 plus the distance from 2 to 3 is less than the distance of 0 to 3. So what is the distance of 0 to 2? 4. What is the distance of 2 to 3? 2 to 3 is 1. Okay, so this is 4, this is 1. So this is less than 7. Okay, 5 is less than 7. Of course 5 is less than 7. So we have to change here, right? So via 2 you have a better distance. Okay, so let's check that. So if you want to go to 0 to 3, it is better to go using 2, right? So 3 plus 1 plus 1, you will get a distance of 5. If you go using 1, you will get 3 plus 4, which is 7. So 7 is not good. Better you can use node 2 and go. So 3 plus 1 plus 1 will be 5. 5 is less than 7, so this is better. So if you want to go from node 0 to node 3, use the node 2. Okay, so that's what we are going to do, and we are going to change the distance here to 5. Okay, now let's quickly see the next possible values. So let's check for 1, 0. So we have to check if 1, 2 plus 2, 0 is going to be less than 1, 0, right? So what is 1, 2? 1, 2 is 1. What is 2, 0? 2, 0 is 4. So we have to check if this is less than 1, 0. 1, 0 is 3. This is not true. Okay, so let's check the next possible case. So we have to check if 1, 2 plus 2, 3 is less than 1, 3. So what is 1, 2? 1, 2 is 1, right? What is 2, 3? 2, 3 is 1. What is 1, 3? 1, 3 is 4. So of course 2 is less than 4, right? So we will make a change and we will make it equal to 2. So we will make it equal to 2. Okay, so what it means is if you want to go from 1 to 3, right? If you want to go from 1 to 3, so use this particular node 2 and you will just get a distance of 2, which is the least possible distance. Okay, so that's it. Now let's quickly see other nodes. So distance between 3, 0, right? So we have to check if 3, 2 plus 2, 0 is less than 3, 0, right? So what is 3, 2? 3, 2 is 1. What is 2, 0? 2, 0 is 4. What is 3, 0? 3, 0 is 7. So of course 5 is less than 7, right? So we will change it and we will make it 5 here. So let's change it, and we are getting a better distance, so we'll make it 5. Let's quickly see 3 1. So we have to check if 3 2 plus 2 1 is less than 3 1. So what is 3 2? So 3 2 is 1. What is 2 1? 2 1 is 1. So we have to check if it is less than 3 1. 3 1 is 4, right? So 2 is better than 4. So we'll change and make the distance equal to 2. Okay. So this distance will become equal to 2. Now that's it. So we have finished for the node 0, for the node 1, for the node 2. Now let's see for the node 3. Okay, 3 is the last remaining node. Now we'll quickly see for the node 3. So if 3 is the pivot, we can just ignore and we can just look here. So let's start for the first possible case. So we are checking if distance between 0 3 plus 3 1, if that is less than 0 1, right? Because we are checking for these cells. So what is the distance between 0 3? So 0 3 is 5. What is the distance between 3 1? 3 1 is 2. So and the distance between 0 1 is 3. So of course it's not valid. Let's go to the next possible cell. So we'll check for 0 2. We have to check if 0 3 plus 3 2, if that is less than 0 2. So what is 0 3? 0 3 is 5. What is 3 2? 3 2 is 1. We have to check if this is less than the distance between 0 2, which is 4. This is not true. Okay, now let's go to the next possible cell. So similarly we'll check for here. So we have to check if 1 3 plus 3 plus 3 0, if that is less than 1 0. So what is 1 3? 1 3 is 2. What is 3 0? 3 0 is 5. We have to check if that is less than 3. This is of course not. So we will go to the next possible case. So we have to check for 1 2. So we will check if 1 3 plus 3 2 is less than 1 2. So what is 1 3? 1 3 is 2. What is 3 2? 3 2 is 1. What is 1 2? 1 2 is 1. This is not valid. Okay, so let's go to the next possible case. So we'll check for 2 0. So we have to check if 2 3 plus 3 0, if that is less than 2 0, right? So what is 2 3? So 2 3 is 1. What is 3 0? 3 0 is 5. If this is less than 4, this is not true. So let's go to the next possible cell. So we have to check for 2 1. So we will check if 2 3 plus 3 1, if that is less than 2 1, right? So what is 2 3? 2 3 is distance is 1. What is 3 1? 3 1 distance is 2. What is 2 1? 2 1 distance is 1. This is again not valid. Okay, so that's it. We have finished iteration for all the possible cells. Now this is the final matrix. Now in this matrix, according to our question, what we'll do, we'll just check. Okay, so we have distance threshold, suppose given 4. So for the first node, we'll check how many distances are less than 4. In this case we have 2. Now next, for node 1 also we'll check how many distances are less than 4. We have 3. Okay, we'll just ignore these diagonal values. For the next city, we'll again check how many distances are less than 4. We have 3. For this also we'll check how many distances are less than 4. We have 2. Okay, so this is the shortest possible path Floyd Warshall algorithm, and in this, using this, we'll be able to find our answer. So now let's quickly go to code this. Okay, so what you have to do is, first you have to declare the distance matrix that we were talking about. So vector int, let me call it dist for distance, and it's going to be of size n cross n. So vector int n, and initially I will give everything as int max. Okay, so all the diagonal values alone I will make it as 0, because the distance from a node to itself is just 0, right? So distance of I is 0. Now what I will do, I will iterate over the edges matrix that is given to me, and I will save that. Okay, so whatever distance directly is given to us, that we have to just save. So in the edges matrix, I am going to, there's a edge between 0 and 1, right? And there's edge between 1 to 0, right? So let me just save this, and what is that? The value of the edge, the distance is given as v of 2, right? So similarly, I'll just give the same condition here, because it's a non-directed edge. Both the edges exist, right? It's a bidirectional edge, so that's why this condition. Now we have to just apply the algorithm. So applying the algorithm is simple. So what we'll do, so we'll take a variable k. This is how many times the loop is going to run, right? So for k equal to 0, k less than n, k plus plus. This is a O of n cube solution. So we have simple 3 for loops, right? So for int I equal to 0, I less than n, I plus plus, and then for int j equal to 0, j less than n, j plus plus. Okay, that's it. Now in this, what we have to do, very simple. We have to check using k, right? K is the pivot. K is nothing but pivot. Okay, using k whether the distance, okay, between ij is getting shortened. So what we have to check, if the distance using k, so distance of ik plus distance of kj, if that is less than, okay, if that is less than equal to the distance between ij normally, okay, so using k we are getting a better distance. That means what? That means this is the better shorter path. So we will just give, if this is true, right, then what is distance of ij? It is just equal to distance of ik plus distance of kj. That's it. Okay, now there is one important condition. This can be int max, and if you add two int maxes you may run into the like problem, because you can not store two int maxes, right, together. You cannot add them. So we will also give this condition that this should not be int max, right? So we will give that condition, this should not be int max. Okay, similarly distance of kj should not be int max. Okay, so distance of kj should not equal to int max. Okay, so we have given these conditions. Okay, that's it. This is our simple matrix of Floyd Warshall algorithm. Okay, now this matrix is fine. Okay, now we have to do what is asked of us in the question. So we have to again iterate over all the possible nodes. So for int I equal to 0, I less than n. For int j equal to 0, j less than n, j plus plus. Again iterate over all the possible nodes and check. Okay, so we will store some, let's say some city is our answer. Okay, and we will take one distance to be, let's say, int max. Okay. So we'll see how many, for each node we have to check. Okay, we have to check how many cities lie within the distance threshold, right? So let me take a local variable here. Okay, let me take a local variable, or better, let me name it as count. Okay, so let me initially take count as 0. Now we will check if distance of ij, right, if distance of ij is less than equal to the threshold that is given. That means we have to increment our count, right? So we have to increment our count. Okay, here we can also check I not equal to j. Okay, so now this will increment our count. Now after this we can check. Okay, so we can check if distance, okay, so we can check whenever we are incrementing the count, that means all the cities in this lie within the distance threshold. Okay, but now we have to find out the city which is the answer. Okay, so what we will do, if count is less than equal to, okay, the current let's say, so let me call it the current city count. Let me call it city count, right? So if count is less than equal to the current city count, that means what? That means that we have a better possible answer. Okay, so we have a better possible answer. So let me declare an answer variable. So what we will do in that case, our answer will become equal to I, which is the node that we are taking. Okay, so this is the condition that we have to check. Also, if this is true, that means okay, city count, let me write city count. Okay, city count will be equal to count. Okay, and this is not needed. So that's it, and we can return answer. So I hope that this will work. Let's run and see if it's working. So it's working fine. Let's submit and see if it's working. So it's working. That's it. Thank you for being patient and